The International Space Station is probably the most fantastic vehicle ever built.
It's a one-of-a-kind laboratory orbiting about 250 miles above the Earth.
And we perform experiments on the International Space Station.
We can do science, we can do experiments, we can learn how to do things out of this world.
And the result will help benefit the people on the ground.
So not only that, but we're also seeing benefits of how we actually assembled the space station.
So the International Space Station in its design was essentially designed like a Lego toy. Lots of big pieces that need to be put together. Some of these pieces are going to be about the size of a city bus.
We needed a way of manipulating or moving these big pieces and very precisely putting them together.
Canada worked with its contractor, which was MDA, and with that company came up with a design that was going to meet the needs of the International Space Station.
The solution to that was using a fairly large robotic arm. And that system ended up being Canadarm2. You could move around the space station, grab payloads, move them to where they needed to be so that the space station could be assembled.
You couldn't have built a vehicle like the International Space Station without a robotic system like this.
And that was when we started talking to Synaptive Medical.
Knowing that MDA has done this before in space, we thought it would be very easy for them to bring that experience and that technology into the neurosurgical area and help us with our medical robotics. We worked with MDA to create Drive. Drive is a robot mounted onto a base that holds a surgical camera that can be automatically positioned to any surgical instrument that's tracked by our system.
What this arm does, it follows you and it tracks you, so it speeds up efficiency.
Ultimately, using the Drive system allows the surgeon to have shorter surgical times, which means shorter recovery times for the patient, and ultimately that's better for the hospital and the patient.
But what the robot does for us is that it allows us to do it safer, we can do it better with less harm to the patient.
The software that runs on the Drive system is directly derived from the software that runs the Canadarm2 on the International Space Station.
Those robotics work with and alongside an astronaut to enhance what they do. So that connection is a very direct and real one.
Right now, it's probably the most used system that we could say is derived from the things we did on the space station. And we're pretty proud of it.
And I've seen the arm before, we've seen it on the space station, but I never put the two and two together that I'd have the same arm in the OR at some time.
I think everybody has this dream of how robotics are going to become more and more a part of everyday life. The things that we do with robotics on the space station is basically pushing those dreams forward. And we evolve the system, we gain the knowledge, we gain the experience, the expertise. So this is kind of the unexpected benefits that we get out of doing a program like the International Space Station.